Again, next section is completing the square. Now, I know you've done this because we did this back in year 10 or down in year 10 in where I'm teaching, so I'm sure you have too. Again, it's a particular technique that you need to learn. And what it does is it creates one of two things. You may remember, depending how far you got in your school, it puts it in a term where you can graph with a perfect square, puts it in turning point form. So it turns a quadratic into turning point form so you can find where that maximum or minimum is. The other thing is, in some cases here, if we get something all squared minus something else, we might be able to keep factorizing. That's not obvious at the start. So let's see if that holds. Let's have a look. Okay. So here's the method here. Okay. There's quite a detailed method out there. Okay. So let's work our way through. You can read that at your leisure. Let's work through, because I know you've done these, and make sure it works. Okay. So we've got them in the form we want. X squared, take 5x plus 4. So here's the important steps. You divide the middle term, or the x coefficient, if you like. Divide the coefficient of x, or maybe I'll write coefficient of x. You're TSFX people, you're smart people, so I'll use the better language. Okay, so I'm going to say divide this number. This number is the coefficient, which means number next to coefficient of x. Divide the coefficient of x by 2. So coefficient of x up here, the coefficient of x is -5. Divide that by 2, you get -5 on 2. Square the answer, 25 on 4. Fantastic, exactly right. Now what you do is you add and subtract this to the second term. This is a really good method you've got here on the screen. This is the best method there is, okay? So you've got x squared, take 5x. After that second term, add 25 on 4 minus 25 on 4. So remember, you can see there, you're adding 0. We're adding 0 to this equation. We're adding 0 to the equation while we bother, because it helps us out when we keep going, okay? So keep going a bit further here. Okay, so the first 3 terms are a perfect square. The first 3 terms are a perfect square, okay? And if you're unsure, this number here is always, this is a big tip, that number there that goes in the perfect square is always your first thing up here. Look at this. That's always the same number every single time ever in the history of the world, okay? Always, okay? So, but those 2 terms form a perfect square. You've got these 2 terms on the end left over. Put them together and off you go, okay? So you've got it in a form like that. So this is the one when we were graphing. If I was going to graph this, and I'm sure you've done some parabolas, what I get is I get a turning point over here. That thing would turn at 5 on 2, -9 on 4. So that's one of the reasons, we do a complete the square, is to get the turning point of a parabola. But in this case here, we can go further, because this is a dots question. This is x take 5 on 2 all squared minus 3 over 2 all squared. 9 on 4 is 3 on 2 all squared. Okay, 3 on 2 all squared. That means we can do dots. Here it is here. A plus B, A take B, and there's our final answer there. Okay. Now, I hope that made sense. I hope that wasn't too fast. But what I would say is, look at all the work we just did. That took us 1, 2, 3, 4, 5, 6, 7, 8 lines of working. So it's a complex, long task. So only do CTS, complete the square, if asked to, or quicker methods do not work. And what I mean by that is, in this case here the question was x squared take 5x plus 4. Now, it's much simpler to say the factors of 4 are 4 and 1. Make them negative, -1, -4. So you do it in one step. So you wouldn't use complete the square for this question, okay? Unless we said use complete the square to do this question, don't do it. Don't do it unless you're asked to, or the other ways don't work, okay? But there are times when you need it, and we'll do one of those in a second. Let's check the question before I move on. How do you recognise when to complete the square in a general sense? That's exactly what we're talking about. Great question. Thank you for asking. So we come down here to another question. let's say I go to this one here, number B, which is 17B. So I'm on 17B, okay, and I'm on page 31. I'm on page 31. How do I factorise? Now, this said to do it, so in this question we've been told to. But if I look at this question here, 25, first thing I'm thinking of, if I'm doing my factors of terms here, I could try 5 and 5, okay, because the factor 25, factors of the last term, 25, are 5 and 5. That gives me 5x and 5x. 5x and 5x gives me 10x, not negative 12x. No good. What else could I try? I could try 25 and 1. 25 and 1, that gives me 25x and 1x. That's not going to give me 12 either. So I've run out of ideas. So there's no obvious factors of 25 that sum to negative 12. That's the problem. In the previous example, the factors of 4 that add up to 5 are 4 and 1. That's obvious. In this case here, it's not obvious. So I need to complete the square. Okay? So let me do this one for you, because some of you may not have done it. If you have already done it, you can scoot on and do question D. Okay, so you've done this, go down to question D. If you haven't done this one yet or not, just follow along with me as we do it. Where's my scroller? Okay, so I'm going to do 17B now. So the technique is, I've got a bit of a mess there, but the technique is this, is you look at the coefficient of x, negative 12. And as a piece of working, you say negative 12 divided by 2. And you get an answer of negative 6. So half of negative 12 is negative 6. You then square that. Negative 6 by negative 6 is positive 36. And that's the number that you add and subtract. So therefore, this thing becomes x squared take 12x. Now we add and subtract that 36. So add 36, take 36. Just like that, add 36, take 36, and I've got that plus 25 still sitting on the end. So all I've done there is I've added 0 to the equation, okay? But then I know the first 3 terms form a perfect square. That's going to be x something all squared. What's the number in there? My first answer up here, x take 6. X take 6 all squared is x squared take 12x plus 36. These last 2 numbers here, neg 36 plus 25, are neg 11. Neg 11, okay? So neg 11 there. Now I've got that in the form where I've got 2 terms, the minus in the middle. So in other words, I can write this as, x takes 6 all squared. What all squared is 11? Just root 11. Just root 11 squared. So x takes 6 all squared minus root 11 all squared, because root 11 all squared is 11. Now I do my difference of perfect squares. Difference of perfect squares is first term plus second term, first term take second term. And there's my final factorised answer, okay? There's my final factorised answer. Tricky, hey? All right, so that's how difference of perfect squares works. If you haven't had a go at it yet, can you go down and have a go at 12D, please? Note here that you must take out the 2 first. So there's our question.